In this example, we're looking to find the line integral over c of 3 times x minus y, all ds, where c is given by the parameterization r of t equals ti plus 2 minus t times j, where t runs from 0 to 2. So we're going to need to set up our formula from before. So our formula is that the integral over c of 3 times x minus y ds. We're going to take the integral from a to b. We'll do f of, we're going to plug in x of t and y of t. And then we're going to multiply this by that arc length formula. So we'll have x prime of t squared plus y prime of t squared, all in a square root. And we're going to take this integral dt. So then we're going to need those different pieces. So let's, as a little bit of side work, find, well, what is x prime of t? Well, x of t is t. So then x prime of t would just be 1. And y of t was 2 minus t. So therefore, y prime of t is going to be negative 1. A is 0 and b is 2. So we have the integral from 0 to 2. We've got 3 times. We're going to plug in x of t for x. So x of t is t. And then we have minus y of t, which is 2 minus t. And then we're going to do the square root. We'll have 1 squared plus negative 1 squared dt. Now we've got the integral from 0 to 2. We'll have 3 times. We have t minus a negative t is really 2t. And then we'll have minus 2. And then times the square root of 1 plus 1, which is square root 2. So the integral from 0 to 2. If we bring things together, then we'll have 6 square root 2t minus, let's see, 6 square root 2 dt. So then we're going to have the 6 square root 2t, we're going to go up to t squared and divide by that new power of 2. Then we'll have minus 6 square root 2, and that will get a t. And then we'll evaluate this from 0 to 2. So when we plug in 2 to the first term, we'll have 6 square root 2 times 4 over 2, so then one of those 2's will cancel. So we'll have 6 times 2 is 12 square root 2. And then we're going to have minus another 12 square root 2. And then when we plug in 0, you just get minus a 0 for that last term. So altogether, we're going to get 0 for this integral.